Have you ever looked at your garden during a dry spell and wished you had an endless free supply of water? Or maybe you've thought about what you would do for water in an emergency if the municipal supply was ever disrupted. The idea of having your own independent water source can seem like a massive, expensive project reserved for professionals with heavy machinery. But what if I told you that for many homeowners, accessing fresh groundwater is a project you can tackle yourself with some basic tools and a bit of good old-fashioned hard work? This guide is all about empowering you to do just that, creating what's known as a sand point well, sometimes called a drive point well, right in your own backyard. This isn't about drilling hundreds of feet through solid rock. This is a simpler, more accessible method for reaching shallow groundwater, the kind that's perfect for keeping your lawn green, your vegetables thriving, and your cars washed without ever turning on the spigot from the street. It's a step towards self-sufficiency, a way to reduce your reliance on public utilities, and a fantastic backup for emergencies. The satisfaction of pumping clear, cool water from the ground with a hand pump you installed yourself is something special. It connects you to your land in a fundamental way, reminding us that with the right knowledge and a little bit of effort, we can provide for ourselves in ways we might not have thought possible. The project we're going to walk through is the installation of a shallow well, using little more than a sledgehammer to drive the pipes into the ground. It's a method that has been used for generations, long before complex drilling rigs became common. It's a testament to simple, effective engineering. By the end of this guide, you'll understand what a sand point well is, what tools you need to get the job done, and every step of the process, from checking for underground power lines to testing your water once you've hit it. This is a project that requires patience and muscle, but it's well within the reach of the average DIY enthusiast. So, if you're ready to roll up your sleeves and invest a weekend into a project that will pay you back for years to come, then you've come to the right place. We'll break it down into simple, manageable steps, making sure you have all the information you need to proceed safely and with confidence. Forget the high water bills for your summer garden. It's time to tap into the free, abundant resource that's waiting just a few feet beneath your feet. Let's get started on building your very own off-grid water source. Before we start swinging a sledgehammer, it's important to understand exactly what we're building. A sandpoint well is one of the simplest types of wells you can install. Think of it as a long, durable straw that you push into the ground until it reaches the water table. The water table is the upper level of an underground area where the soil and rock are saturated with water. Once your straw is in this saturated zone, you can use a pump to draw the water up to the surface. It's a beautifully simple concept that works very effectively in areas with the right geological conditions, specifically places with sandy or loamy soil and a relatively high water table, typically within 25 feet of the surface. The sand point itself is the star of the show. It's a hardened, pointed cast iron tip designed to pierce through soil, clay, and small gravel. Just above this point is a section of pipe covered with a very fine stainless steel mesh screen. This screen is the filter. It allows water to seep into the pipe while keeping sand, silt, and other sediment out. This is crucial because you want to pump up clean water, not a muddy slurry that will clog your pump and your pipes. The sand point is attached to sections of galvanized steel pipe, which are driven into the ground one by one until you reach the desired depth. The reason this method is so accessible for a DIY project is that it doesn't require a massive drilling rig. Instead, you use brute force. By hammering on the top of the pipe assembly, you slowly but surely drive the point deeper and deeper. The entire system is designed for this process. Special well couplers are used to connect the pipe sections, and a heavy-duty smash cap is threaded onto the top to take the impact of the sledgehammer, protecting the pipe threads from being damaged. This setup allows you to create a well that can be 15, 20, or even 25 feet deep using nothing more than hand tools. It's important to note the limitations, however. Sandpoint wells are not suitable for every location. If your property sits on top of solid rock or dense, heavy clay, this method simply won't work. You need to be able to drive the point through the ground. They are also limited in depth. The type of pump we'll be using, a manual pitcher pump, can only lift water from a maximum depth of about 20 to 25 feet due to the physics of atmospheric pressure. But for countless properties with the right conditions, a sandpoint well is the perfect low-cost solution for accessing an abundance of non-potable water for all your outdoor needs. A successful project always starts with having the right tools and materials laid out and ready to go. For this job, you won't need a truck full of specialized equipment, but getting the correct components is non-negotiable. Let's go through the list. First, the well itself. You'll need a 1¼ inch diameter sand point. This is a common size that's sturdy enough for driving. You'll also need several sections of 1¼ inch galvanized steel pipe, typically sold in 4 or 5 foot lengths with threaded ends. How many you need depends on your local water table depth, but starting with 4 or 5 sections is a good bet. You can always get more if needed. Next are the specialty fittings that make this whole process possible. You'll need well couplers, which are different from standard plumbing couplers. They are designed so that the pipe ends butt up against each other inside the coupler, allowing the force of the hammer blows to transfer through the entire pipe column without destroying the threads. You will also need a smash cap or drive cap. This is a solid, heavy-duty cap that threads onto the top of your pipe. It's made to be hit repeatedly with a sledgehammer, protecting the pipe itself. Do not try to hammer directly on the pipe or a regular plumbing cap. You will ruin your threads and your day. For tools, the main event is a good sledgehammer. Something in the 8 to 12 pound range is ideal. Heavy enough to do the work, but not so heavy that you'll exhaust yourself in minutes. You will absolutely need 2 large pipe wrenches, at least 18 inches long. You need one to hold the pipe steady, and another to tighten the couplers. Getting these connections incredibly tight is critical to the well's integrity. You'll also want a post hole digger or a sharp spade to get your initial hole started, which helps you get past the first few feet of topsoil, roots and small rocks with ease. Finally, let's talk about the sealing and pumping components. To ensure your threaded connections are both watertight and airtight, you'll need pipe dope, also called pipe joint compound, and Teflon tape. Make sure the pipe dope is rated as safe for potable water systems, even if you don't plan on drinking it. It's just good practice. And of course, you'll need your pump. A classic manual pitcher pump is the perfect partner for a sandpoint well. It's simple, reliable, and powerful enough to pull water from 20 feet down. Make sure you get one that is compatible with the 1¼ inch pipe diameter you are using. Before a single shovel of dirt is moved, we have to talk about the most important step of the entire project: safety and preparation. The ground beneath our feet is often crisscrossed with a network of invisible and potentially dangerous utility lines. Hitting a buried electrical line, natural gas pipe, water main, or sewer line can lead to serious injury, property damage, and costly repairs. This is not a step to be taken lightly or skipped. In the United States and Canada, there is a free service you must use before any digging project. You simply need to call 811, the call before you dig hotline, a few days before you plan to start. When you call 811, you'll provide them with the location of your planned digging. They will then notify all the relevant local utility companies. Within a few days, representatives from each company, electric, gas, water, cable, and so on, will come to your property and mark the location of their buried lines with small flags and spray paint. This service is completely free, and it is the law. Once the area is marked, you will know exactly where you can and cannot dig. Choose a spot for your well that is a safe distance away from all marked lines. This simple phone call is the single most important thing you will do to ensure your project is safe from start to finish. With safety addressed, the next phase of your prep work is research. You don't want to start hammering a pipe into the ground without having a reasonable expectation of finding water. A great place to start is the United States Geological Survey, which has extensive online data about groundwater levels across the country. You can often find maps and records for your specific area that will give you an idea of the typical depth of the water table. Another fantastic resource is your local community. Talk to neighbors who have wells, or visit a local well drilling supply store. These folks often have decades of localized knowledge and can tell you if sandpoint wells are common and successful in your town. Finally, you must check your local regulations. While simple, non-potable sandpoint wells are often exempt from the strict permitting processes required for deep-drilled drinking water wells, this is not always the case. Some towns, counties, or homeowners associations may have specific rules about where you can install a well, how deep it can be, or if they are allowed at all. A quick call to your local city or county planning or building department can clarify the rules. Taking the time to do this due diligence, calling 811, researching water depth, and checking local codes will save you a world of potential headaches and set your project up for a smooth, successful, and safe installation. Now that your site is selected and you've done your homework, it's time to get your hands on the materials. The first step, and honestly, it's one that is often overlooked, is to thoroughly clean all of your pipes and the sand point itself. New galvanized pipes often have a light coating of oil or other manufacturing residues on the inside. You really don't want that in your well water, even if it's just for the garden. The cleaning process is simple. You can use a long bottle brush, a rag tied to a rope, or a purpose-built pipe brush. Just run it through each pipe section with some biodegradable soap and warm water, then rinse them out completely until the water runs clear. Once the pipes are clean and dry, you can begin the initial assembly. This is where you'll get your first feel for how the components fit together. Start with the sand point. Apply a generous amount of pipe dope to the male threads at the top of the point. Then, wrap the threads with 2 or 3 layers of Teflon tape over the pipe dope, wrapping in the same direction that you will be tightening the pipe, which is clockwise. This combination of dope and tape creates a very robust leak-proof seal that is essential for the suction your pump will need to create. You don't want air leaking into your well column, as it will prevent the pump from drawing water effectively. Now, take your first section of 4-foot pipe and thread it into the sand point. Use your 2 large pipe wrenches to tighten this connection as much as you possibly can. This is not a time to be gentle. Brace the sand point against something solid, or have a helper hold it steady with one wrench while you apply maximum force with the other. Every threaded connection in the well column needs to be absolutely rock solid. The immense force and vibration from the sledgehammer will try to loosen these joints, so making them incredibly tight from the start is your best defense. A loose joint will fail during driving or will leak air later on. After connecting the first pipe to the sand point, you'll move to the other end. Here, you will attach one of your special well couplers. Again, apply a liberal amount of both pipe dope and Teflon tape to the male threads on the pipe before threading on the coupler. Tighten it with everything you've got. Now you have a single, approximately 8-foot long assembly consisting of the sand point, the first pipe section, and a coupler on top, ready and waiting for the next pipe. This initial preparation ensures that when you start driving, your focus can be on the work itself, not on fixing sloppy connections. With your initial section assembled, the real work begins. Start by creating a pilot hole. Using your post hole digger or a sharp shovel, dig a hole as deep as you can comfortably go, ideally around 3 to 4 feet. This serves a few important purposes. It allows you to get past the dense mat of surface-level grass roots, topsoil, and any small, near-surface rocks that might deflect your sand point. It also gives you a straight, vertical starting point, ensuring your well begins its journey downward correctly. Once your hole is dug, carefully lower your sand point and first pipe section into the center of the hole. It should stand vertically on its own. Now it's time to prepare for hammering. Take your second section of pipe and apply pipe dope and Teflon tape to the threads. Screw it into the coupler that is already on top of the first pipe section, and once again, use your 2 pipe wrenches to make this connection brutally tight. With that done, you're ready for the smash cap. Apply a bit of pipe dope to the threads on top of this second pipe and screw on the heavy-duty smash cap. Tighten it firmly with a wrench. Your well column is now about 12 feet long, with the smash cap on top, ready to take the punishment of the sledgehammer. Climb onto a sturdy step stool or small step ladder so you can get a good, controlled downward swing onto the smash cap. Safety is key here. Wear safety glasses, gloves, and sturdy boots. Start with firm, deliberate blows directly onto the center of the cap. Don't swing like you're trying to win a prize at the carnival. You're looking for consistent, solid hits that drive the pipe steadily into the ground. You'll quickly find a rhythm. The pipe will move an inch or a fraction of an inch with each hit. As the pipe goes deeper, the sound will change, and the resistance will likely increase. This is normal. This is a marathon, not a sprint. After every foot or so of progress, about 20 to 30 swings, stop. Use your pipe wrenches to check and retighten every single connection, including the smash cap itself. The vibrations from the hammering will work to loosen the threads, and a loose joint is a point of failure. It might seem tedious, but this is a critical maintenance step during the driving process. Once the top of the pipe gets down to about your chest level, you'll stop, unscrew the smash cap, and repeat the process. Add another section of pipe with a new coupler, tighten everything down, reattach the smash cap on top, and continue driving. How do you know when you've hit water? You won't see a geyser erupting from the ground. The sign is much more subtle, and it requires you to stop and check your progress periodically. A good rule of thumb is to start checking for water once the sand point is about 12 to 15 feet deep, especially if your research indicated a high water table. To check, you'll need a long weighted string or a measuring tape with a small weight on the end. Unscrew the smash cap from the top of your well pipe, and carefully lower the weighted string all the way down until you feel it hit the bottom of the sand point. Pull the string back up and check the lower portion of it. Is it wet? If the string comes up damp or wet, congratulations. You have successfully reached the water table. The length of the wet section on the string tells you how much standing water is currently inside your pipe. For example, if the bottom 2 feet of the string are wet, it means you have 2 feet of water in the pipe. This is a fantastic sign, but your work isn't done yet. You don't want the screen of your sand point sitting right at the top of the water table, which can fluctuate with the seasons. Once you confirm you have hit water, the goal is to drive the well at least 1 full pipe section deeper. This means if you hit water at 16 feet, you should aim for a final depth of at least 20 feet. By driving the well an additional 4 or 5 feet below the point where you first encountered water, you ensure that the screen section of your sand point is fully submerged deep within the saturated aquifer. This provides a much more reliable water source, as it will still be in the water even if the water table drops a few feet during a dry summer. It also gives you a larger column of water to draw from. So, after your celebratory moment of finding water, get back to work. Reattach the smash cap, and continue driving the pipe down that final, crucial length. You might notice that the driving becomes a bit easier once you're in the fully saturated sand or soil, as the water can lubricate the path of the point. Once you've reached your target depth, at least 1 full pipe section past the initial water strike, you can stop driving. Perform one last check with your weighted string to confirm you still have a good column of water inside the pipe. Now, the heavy labor of driving the well is complete. With the well pipe driven to its final depth, you are ready for the most rewarding part of the project, installing the pump and seeing the fruits of your labor. We're using a manual pitcher pump, a timeless piece of technology that is perfect for this application. Before you install it, there's a small but important preparation step. These pumps use leather gaskets or leathers inside to create the seal needed for suction. If the pump is new, these leather components will be dry and stiff. To make them pliable and effective, you need to rehydrate them. Simply place the entire pump, or at least the lower portion containing the gaskets, into a bucket of water and let it soak for at least an hour. While the pump is soaking, you can prepare the top of your well pipe. Unscrew the smash cap for the final time. Clean the threads on the top of the pipe to remove any dirt or excess pipe dope from the driving process. Just like with all the other connections, you'll want to create a perfect, airtight seal. Apply a fresh layer of pipe dope rated for potable water to the threads, followed by several wraps of Teflon tape. The pitcher pump will have a threaded female connection at its base, designed to screw directly onto your 1 1/4 inch well pipe. Once the pump has finished soaking, retrieve it from the water and carefully thread it onto the top of your well pipe. Hand tighten it until it is snug, positioning the handle and spout in the direction you want them to face for convenient use. Then, use a pipe wrench on the base of the pump to give it a final quarter turn to ensure it is tight. Be careful not to over-tighten and crack the cast iron base of the pump. The seal needs to be airtight, but you don't need the same brute force you used on the couplers that had to withstand the sledgehammer. The pump is now physically installed. The final step before you can get water is called priming. A pitcher pump cannot pull water all the way up from 20 feet below if the pipe is full of air. It needs a column of water to work against. To prime it, you need to pour water into the top of the pump. Pour about a quart of water directly in, right where the pump handle connects. You will hear it gurgle as it runs down into the pipe. Once you've added the water, you can begin to pump the handle. At first, you'll just be moving air and the priming water, but after 20 or 30 steady strokes, you should start to feel the resistance increase as the pump begins to lift the entire column of water from the aquifer below. The moment has arrived. After priming the pump and working the handle, you will see the first surge of water emerge from the spout. Don't be alarmed when this initial water looks terrible. It will almost certainly be brown, silty, and full of sediment that was disturbed during the installation process. This is completely normal. Your job now is to simply keep pumping, Place a bucket under the spout and just keep working the handle. For the first 10 to 15 minutes, you will be flushing the well, clearing out all the loose sand and silt from around the well screen. You will see the water quality gradually improve, going from muddy brown to cloudy, and finally, to crystal clear. Once the water is running clear, you have a functional well for irrigation and general outdoor use. However, and this is the most important piece of advice in this entire guide, you must not assume the water is safe to drink. Groundwater can be contaminated with bacteria, nitrates, heavy metals, or agricultural runoff that are completely invisible to the naked eye. To determine if the water is potable, safe for drinking, you must have it professionally tested. Contact your local health department or a state-certified water testing laboratory. They will provide you with a sterile collection kit and instructions. It's a small price to pay for peace of mind. Of course, not every project goes perfectly. What if you run into trouble? The most common issue is hitting a large, immovable rock or a layer of hardpan clay while driving the pipe. If you are hammering and the pipe simply stops moving no matter how hard you hit it, you've likely hit a major obstruction. Unfortunately, the only solution is to pull the entire pipe assembly out of the ground and try again in a different spot a few feet away. Another issue can be not finding water. If you drive the pipe to 25 feet and your weighted string still comes up dry, the water table in that spot is likely too deep for a sandpoint well. This project is a powerful demonstration of what you can accomplish with simple tools and determination. It connects you to a fundamental resource and provides a real sense of self-reliance. While success isn't guaranteed, the geology under your feet is the ultimate decider. It is a project that is well within the capabilities of most people willing to put in the effort. With careful planning, a commitment to safety, and a good bit of patience, you can build a water source that will serve you for years, whether it's for growing a beautiful garden or just having a reliable backup in case of an emergency.